Hi, in this unit we're going to be talking about acids and bases equilibrium. So first let's review the strong acids and bases. Strong acids. Now there are 6 strong acids that we're going to be using in our AP chemistry, and they are HClO4, perchloric acid, HI, hydroiodic acid, HBr, hydrobromic acid, HCl, hydrochloric acid, HNO3, nitric acid, and H2SO4, sulfuric acid. Acids are molecules and therefore ionizing water, and since these are strong acids, these will completely ionizing water. Now let's talk about strong bases. Now all group 1A hydroxides are strong bases, and Ca2+, Sr2+, any hydroxide with Ca2+, Sr2+, and Ba2+, are all strong as well. And Mg2+, you should assume that it's strong unless it's otherwise noted in this unit. Now, because these compounds contain hydroxides, they're ionic and therefore dissociating water. And now these strong hydroxide will dissociate 100% completely in water. Okay, now let's get to the main topic we're going to talk about today. The strength of an acid is measured by its tendency to ionize. Acids ionize because the water molecule attracts the H bond, forming H3O+. And now there are 3 factors that influence the extent to how strong an acid is. Now this is only acids. How do you determine how strong an acid is? There are 3 things. 1, the length between H and X bond in binary acids only. Next, we have different number of oxygens in oxyacid. And third, we have different central atom in oxyacids. Okay, so first let's look at the length. So a larger atom will result in a larger bond length, right? Let's take an example of HCl and HI. HCl and HI. So we have a hydrogen over here, and chlorine is bigger than hydrogen. So let's just draw it like this. This is the distance in between these. This is HCl. We call this distance. This is the distance between the two this is the distance between the 2 atoms. Now HI, this is still our H, and I is all the way down on the periodic table at number 53. So it's much bigger. And this is the center. Now this distance will be longer than this distance. And the longer the distance, the longer the bond length between the H and the X, the weaker the bond. Right? Because it's longer, it has less attraction from the nucleuses, and the bond is weaker. Now, a weaker bond means it's easier to remove the H+, easier to remove the H+. Longer bond length means easier to remove the H+, because that's how ionization works, and ionizing energy works. And finally, that will result in a stronger acid. If it's easier to remove the H+, then that means it will be a stronger acid, because it will be easier to dissociate completely in water. Now our second type, if we're given oxyacid now, oxyacids contain X, H, and O. Adding oxygens to the central atom causes a shift in electron density toward the central atom. And this is known as inductive effect. Now this shift will cause the OH bond to become more polar. And greater polarity causes the water molecule to be more attracted to the H, causing the acid to ionize. So basically, when you're given with oxyacids and the central atom is the same, alright, this central one is the same, the more oxygen there is, the more the more polar it will be, and the stronger the acid will be. So let's say we have HCl. So let's take a look. So let's take a look at HCl family. All right, HClO will have the weakest. Will be the weakest acid. HClO2 will be stronger since it has more oxygens. HClO3 will be even stronger, and HClO4 will be the strongest of the four because they have the most oxygens. Now, what if the number of oxygens is the same and yet the central atom is different? So let's say we have O bonded to X bonded to H, and O bonded to Y bonded to H. Now, in this case, the more electronegative one will have a stronger polarity, which means it will be the stronger acid. So let's assume Y is more polar. No, Y has a stronger electronegativity. Again, reminder, electronegativity increases as you go toward the right and decreases as you go down. All right, so and F has the strongest electronegativity. So let's assume Y is more electronegative. That means the inductive effect increases polarity of the OH bond in the Y. Now, greater polarity causes the water molecule to be more attracted to H, causing the acid to ionize more readily. Now, the greater polarity causes a water molecule to be more attracted to H, and thus causing the acid to ionize more. Now over here, let's replace X and Y with Br Y equals Cl. And now Y is still more electronegative, right? Cl is more electronegative than Br because Cl is closer to fluorine on the periodic table than Br. Now the Cl in the electrons it shares with. Now Cl attracts the electrons it shares with oxygen to a greater extent, the OH bonds. And this means the OH is therefore more polar. And what does more polar mean? More polar, it means it will be easily more ionized. And so now because HClO3 is more polar, it is a stronger acid. Now this only works in oxy acid when the number of oxygens is the same and the central element is different. To summarize, we have three things that that determines how strong an acid will be. First of all, it's the distance. Greater distance means stronger acid. Second, we have number of oxygens in oxy acid. Now, number one is only dependent in binary acid. Second one and third one are for oxy acids. Second one, number of oxygens in oxy acid. More oxygens equals stronger acid. Now, what if the oxygen number is the same? Number three, it's electronegativity. Now, if the number of oxygens are the same, stronger electronegativity will equal a stronger acid. Now that's it for this video. Thank you for watching.